Okay, so Introduction to Data Collection and Organization Activity Sections 1 through 4. So in this video, we're just going to do sections 1 through 4. So on most of this video, at this point, you're going to have to print off all of your units from My Math Lab, and you can either just watch the video to do your homework, or you can print them off, which I would recommend if you have a printer at home, and just take notes from this. So we're going to go through and just talk about notes. So I'm basically going to go through these with you, and what I would suggest is that you take notes before we have class. We're not going to do them as a class because not everybody is going to be able to do this online as well during class. So do them before class, and then during class time I'll use that to answer questions or help you with things that you don't understand. So instead we're going to do a version of flipped class where you are going to basically watch the video, take notes, and then if you have questions you can ask during class. So we're going to read through this right now. And so it says, researchers collect data to help politicians, consumers, businesses, doctors, patients, just about everyone make informed decisions. Often researchers need to find information about large populations. So there's my first term that we want to look at is population. It can be impossible to collect data from every member of the population. Instead, their goal is to choose a sample that best represents the interest and collect the data from just the sample. So we're going to talk about just your definitions for a minute. So our population, basically think of your population as the whole or every member. Think of it like your all. And then your sample is your part or your segment of the population. Okay, so when we think of these, and sometimes when we want to specifically talk about samples and populations, the main thing I want you to remember, oops, let me make this smaller, and I'm going to move this up here, is the main thing when I talk about samples and populations is keywords. So for population, it would be things like all frogs, all cats, all adults. Whereas sample, I'm specifically either going to give you a number, say like 500 frogs, a few cats, 52 adults. I'm either going to give you a specific number or I'm going to narrow it down to a specific part of your sample, like a few cats or some cats. Okay, on problem number 1, they want you to read through this and tell them what the sample and the population is. So my sample are going to be those things that have numbers associated with them. So for example, like my 2,096 registered voters, some dealerships in the Midwest, 500 women of childbearing age. So that is my sample, is the 2,096 registered voters. And in this case, on number 2, they didn't have a number listed, but they said some dealerships. I can't spell dealerships. Where's my eraser? Okay. Dealerships. And then 500 women of childbearing age. And then on my population, that's basically your your large group. That's all your dealerships, all your Americans, all your women trying to get pregnant. So that is all your Americans. This is all your dealerships. This is all your women of childbearing age. That's the main key, is to look at your sample has a number or a part associated with it, and your population is all Americans, all dealerships, all women of a certain age. Okay, so the next section is talking about the different types of variables. So the two types of variables that we are dealing with are your numerical values and your categorical values. Your numerical values are measurable or counted quantities. So those things that are measurable, whereas categorical are qualities. So think of numerical as measurable numbers, whereas categorical, think of them as things that are words, things that describe them, like they're blue. You're saying yes or no, your color of your eyes, the color of your hair, the color of your fingernail polish, the color of your shirt. There are some exceptions to things that look like they're numerical, but they might be categorical. So for example, why is my pen not working? Let me try a different color. Okay. For example, like your zip code. So my zip code might be 78621, something like that. Okay. Even though this is a number, it's not a measurable number. So therefore, this is categorical. So a zip code is one of those things that is the exception to the rule, where that is categorical. All right, number 4, they want to consider the variables from the first two studies in the previous page, fill out the missing information on the table, determine whether they're numerical or categorical. So when we talk about registered voters, age 18 to 24, that is my subject. The data that was recorded from each subject, that was a yes or a no. So the type of variable that is, since you answered yes or a no, you used words to answer your question. So that's categorical. And then if you look, the summary of the data, they said it was 39%. So even though this is a number, it's not considered categorical. I mean, it's not considered numerical, because the answer to the question is whether they approved or not, and they said yes or no. And so that means it's categorical. So that is the answer to that. And so then the second one, the dealership rate in the Midwest. And on that, the answer to that was when they asked them like how many cars were sold, they asked the number of cars sold. So they actually gave them a number, a measurable number. So that's numerical. And their answer was an average of 12 or more cars per week. So that's the difference. Numerical is a measurable number. Categorical is basically a word. Okay, part 3. They're giving you a two-way table again. We've talked about two-way tables before. We've done this several times before. You've got one category up here where you're pregnant or not pregnant, and so what you actually are, and then you have whether you tested positive or negative on the left side. So now we're going to look down here, and then instead of saying pregnant or not pregnant, even though this is a number, this is not a measurable number. Think of this as just binary. They put a 0 here. Basically, think of a 1 being a yes, you're pregnant, and a 2 meaning you're actually not pregnant. So 1 is a yes, 2 is a no. Or 0 is a no, not a 2, a 0. I don't know why they did zeros and ones, but I guess they didn't want to confuse positive and negative and yes or no. So I guess that's why they did it. So not 0, 1, 0. So 1 is pregnant, 0 is not pregnant. So instead of saying yes and no, and then positive and negative, that's how they did it. So if I look at a negative and a 0, meaning my test result was negative and I wasn't pregnant, that is a D. And then positive and 1, so positive and 1 pregnant is A. Sorry, I'm going to have to write kind of big on this because the screen's really small. And then positive and 0, positive and not pregnant is a B. Negative, negative and not pregnant, negative not pregnant is a D. Negative and pregnant is a C. Negative and not pregnant is a D. And then positive and pregnant is an A. So that's how you do the two-way tables on those. So it says, we saw at the top of this page that the two-way tables can be used to organize for two categorical variables. What are the two categorical variables? So our two categorical variables were your pregnancy status, that's an R, status, and your test results, positive or negative. 6 says, explain how we know that each is categorical. So basically we know that they're categorical because you're either answering yes or a no, and you're answering positive or negative. So even though for pregnant or not pregnant, you answered a 1 or a 0, it's still not measuring anything. That's still binary. It's still categorical. So you basically answered with words and not measurable numbers. 1 and 2 are not measurable numbers. We would not consider those measurable numbers when they're binary. So then the next part is filling in the table, and you've already done these before. 450 minus 45, that's going to give me 405. 405 plus 5 is 410. 500 minus 410 is 90. 90 minus 45 is 45. 40 plus 5 is 50. And so we're going to use this on the next screen. So we basically have done a whole bunch of these anyway, and we're going to kind of do these again on the next screen. Okay, number 1, we've kind of done these before, but we're going to get a little more specific on this. It says, how many of these test results were negative? So if I look at negative, we have 410 test results were negative. That's this number here. It says, of those test results, so all they want to basically do is look at this row. Of those, how many of those tests were false? Meaning that if it tested negative, they were actually pregnant. So that's going to be 5. And so remember, you're doing whole, part. So I want to know what percent of the whole. So what percent of the 410 is false negatives? So we have X times 410, oops, that needs a 1 there, equals 5, and then I divide by 410, and I'm not going to worry about if you write complete sentences on this. So 410 divided by 5, let me get out my calculator, sorry, 5 divided by 410, not 410 divided by 5, gives me about 0.012. And if I move that over 2 decimals, that's about 1.2% for this. Then the next one, it says, how many of these had positive test results? How many had positive test results? So there were 90 positive tests. And of those tests, how many had false positives? So if they were positive, I wanted to know how many were actually not pregnant, and there were 45 of them. This one you can probably guess, because 45, you've got 45 and 45. So X times 90 equals 45. Divide by 90. You get X equals 0.5. And if I move that over 2 decimal places, that's 50%. And then part G, I'm not going to worry about answering the question. I just want y'all to solve the math problems on those. Okay, number 1. Let me redo these numbers. This is 405, 410, 90, 45, 50. Okay, so we're going to translate this as is. This says what percent of the sample, there's 500 in the sample, were actually pregnant. So my were actually pregnant, there's 50 that were actually pregnant. So my x times 500 equals 50 divided by 500. That gives me 0.10. So that's going to be 10%. And then the next one, what percent of the pregnant women? So my pregnant women, I had 50 pregnant women. So of my 50 pregnant women, how many were given a negative result? That was 5 of them. So remember, you're looking only at the pregnant women group, so you're only looking at this group. So of the pregnant women, there were 50 pregnant women, only 5 of those were negative. So I'm going to divide by 50. So my x equals 5 divided by 50, which gives me 0.1, which is again 10%. Next one says what percent of women who were not pregnant, so that's 450, were given positive test results. So in that group, 45 were given positive test results. I'm only looking at that group. So 45 divided by 450 is 0.10. That's 10%.